the 20th century, remember? Einstein developed his theory of relativity. A new awareness was growing on the constitution of matter. Theories were overhauled for two pivotal elements, mass and energy. Mass and energy are related and can be converted into each other. But why do particles have the masses we observe? Ideas we do have are described in what is called the Standard Model. The Standard Model does answer questions about structure and stability of matter, and about the fundamental forces. The building blocks of matter, the basic particles. Today we recognize three families, of which only the first family can build what we know as stable matter. Each family has 4 members, 2 quarks and 2 leptons. Thus divided, we see in the first family the up and down quarks, the neutrino, and the electron. All these particles have their own mass. The particles in the second and the third family are unstable and they decay. But they must have been important in the very early stages of our universe. There is so much more to tell about matter and antimatter, for instance. How can we perceive it? So much more that raises questions, too. Take the forces involved. We can now distinguish 4 different forces in nature. Some names are familiar: gravity, electromagnetism, and then weak force and strong force. All these forces are transmitted or carried by particles of force, a different kind of particle, each given its own name. There's the strong force, holding the quarks together, forming the proton, and forming the neutron. We say that this force is transmitted by the gluon. There's electromagnetism, playing a role in the existence of the atom. This force is transmitted by the photon. The 2 other fundamental forces are also linked with particles. Like the basic particles, force particles also have their own mass. There is a concept of an underlying symmetry. We call it supersymmetry. Atlas will search for evidence of this symmetry. Mass. Where does it come from? Some particles have a huge mass. At this point in time, we have theories proposing that mass is generated by a process known as the Higgs mechanism. If it exists, another particle has to be involved as well, the Higgs particle. It could be the ultimate creator of mass. One goal of the ATLAS experiment is to search for this particle and to reveal its properties. And why is a recurring word. Why only 12 basic particles? Why only 3 families? It's the why of our physics, as developed over centuries, coming to this point in time, point 2000 you could call it. "34 countries cooperate in ATLAS. The concentration point is CERN, Geneva. Here, the ATLAS detector will be integrated in the LHC, the accelerator that is the next step in our quest for answers. Beams of protons will collide with each other at an amazing energy of 14 TeV. Here we find superconducting magnets on a scale never before constructed. This huge accelerator, assembled in the same tunnel as its predecessor, is the new tool for a variety of experiments.